Welcome in lecture series of electrical installation and practices. In the previous lecture, instrument transformer, CTs, PTs, measurement of current, voltage, energy, these points has been discussed, including the CT-PT installation in the substation. For today's topic is the low voltage and high voltage cables. The lecture contains construction of cable, size and current rating of different type of cable, termination and joints. What is the difference between termination and joint? This one. HT cable, type of HT cable. What is the constructional difference between LT cable and HT cable? And some sort of cable testing. So part of cable. Cable is used for the transmission of power. Then the cable is called as a power cable. Whereas there are multi-core cable which is used for signal transfer. It is called as a control cable. So it is consist of number of cores is more than 3, 6, 9, 12, 30 cores cables. So different type of cable, different core of cables are used. Core is the aluminum core. It may be the copper core. Here, this is the aluminum core. It can be a copper. So it will be a copper cable. So the core is going to carry the current or power in the cable. So this is the part of LT cable. LT cable is a low voltage up to the 1100 volt. The cable is called as a LT cable. So what are the different part of the cable? One is the core, which is going to transmit the power. The core size is available in the different, these are the standard size, say 1 square mm, 1.5, 2.5, then 4 square mm, 6, 10, 16 square mm, 25, 35. These are the square mm, means the cross-sectional area of conductor in the 2.5 square mm, 4 square mm, 35, 50 square mm, 75 square mm, 90, 110, 150, 185, 220, 285 or 300. These are the some standard size which is used across the country or it is acceptable everywhere. So these are the standard size of aluminum cable or it may be the copper cable. So this is the core which carries the current. It is having number of strands for reducing the skin effect and to make the cable flexible for transportation, installation, laying. So it is necessary the cable can be handled in the form of round. Say round means it is in the drum. We can transport over the drum. So it is therefore the core is not a solid core. Suppose this is the 50 square mm. It is not a solid conductor, whereas there are different size of conductors are bound together to make a 50 square mm. So the insulation difference, insulation between these two core is this is a PVC or XLPE, cross-linked polyethylene. Nowadays rubber we are not using, we are using XLPE insulation, that is called as a cross-linked polyethylene insulations. So this is called XLPE cables are there. So XLPE cable over which there is some rubber is made to protect the XLPE insulation. So this is used to protect or to avoid the water particle or moisture to enter between the two core of the cable, which will increase the insulation level. Now over this rubber or inner sheet, we have a armored. Armored is used for to protect the cable by mechanical injury, because the cable is going to lay underground. It may going to lay over the cable tray. It is a fabricated tray. So to avoid the mechanical damage or to make the cable stronger, mechanically stronger, we are using armored over this one. And to protect the armor with moistures or some other mechanical injury, again outer sheetings are used. So this is one type of rubber or XLPE material. Again, this is also XLPE material. So this it will provide the insulation between conductor to conductor. It will provide the protection to enter the moistures or water in the core of the cable. It is used for mechanical injury, and it is used to protect the armored or to make the cable stronger. So this is somewhat the construction of cable. Now, LT cable. LT cable, it may be a 4-core, it may be a 3.5 core. So up to generally 35 square mm, 35 square mm cable is available in 4-core, whereas more than 35, 50 square mm, so it is 3.5, means this is 4-core. So you can write here 4 into 35 square mm. It indicate the number of core is 4. This is core, means the core, this is 1, 2, 3, 4. This is the core, and 35 is the cross sectional area. This is the cross sectional area is 35 square mm, whereas this is the core. So 1, 2, 3, 4. Whereas more than 50 or 50 square mm, it is written as, it is available in the market 3.5 into 50 square mm, where 3 core is used to carry the power or current, and whereas half of the core is used to carry the neutral current. So under balance load condition or 3-phase balance load, the neutral does not carry current. Therefore, we are using the neutral core is half of the phase conductor, which will reduce the cross-sectional area of the cable, which will reduce the cost of the cable, as in case of balance condition, the current in the neutral conductor is 0. But if we are using the cable for lighting load or some commercial building where maximum loads are available in single phase, so there is a chances, or most of the time, the load is not balanced, or their diversity in such a way that 2 or 3 phase, there will not be a balanced load condition. So under unbalanced load condition, neutral carries current, so it is recommended to use the 4-core cable to carry the current, to carry the neutral current. So this is one. This is also the cable. So it is inner sheet. This is 2 is the inner sheet, which is used to protect a water particle inside the 2 sheet, or 2 say conductor to conductor. This is armored. So it is a round armored. It is a flat armored. For small cables, small size of cable, say 50 square mm, 35 square mm, many times the round armoreds are there. And but for the higher capacity or higher size of the cable, we are using the flat armored is there. This is used for the this one. And this is the copper conductor. So instead of using aluminum, this will be the copper conductor. But the copper conductor is costly, and advantage is that it carries more current. So whatever when the size is concerned, when the size of the conductor is required is small, or space is small, it is recommended to use the copper conductor or copper cable. So this is called as a armored cable, whereas some of the cables are unarmored, or it is a flexible cable. So this is 3-core flexible cable where stranded wires are there, which is 3-core cable. This is the 3-core. Say the size of the wire is 1.5 or 2.5 square mm. So it is 3-core 2.5 square mm copper flexible cable. This is also the flexible cable. Sometimes we will use the flat cable. The flat cable is used for the submersible pumps, whereas the round cable can be used everywhere. So this is the say LT cables are there. Now this is the chart. So see here, this is the cross-sectional area of the conductor. whatever it may be, the 4 core, 3 core, 3.5 core. So standard size is 4, 6, 10, 16, 25, 30, 50, 70, 95, 120, 150, 185, 240, 300. These are the standard size available across the globe. And these are the current carrying capacity in the different conditions. Say, for example, DC resistance. What is the DC resistance for the aluminum? It is 7.41 ohm per kilometer. Whereas for the higher size, it is 1.92 kilometer per ohm. For the copper, the resistance is small. See here, it is the aluminum, whereas the size is same. The resistance per kilometer is 7.41. For the copper cable, it is 4.61. Whereas for the AC resistance, it is 9.41. See, this is difference. For the DC current, the resistance per kilometer is 7.41 ohm per kilometer. This is the resistance. Whereas for the AC current, the resistance become 9.48 ohms per kilometer. The reason is for AC, there is a skin effect. Skin effect is that the current try to flow over the surface of conductor. So here the current is going to flow surface of the conductor. At the center, the current density will be small. So that's why the effective cross-sectional area of conductor is not going to utilize for the AC. That's why the resistance per kilometer of AC current is higher one. So this is same 35 square mm 0.868. Here 0.572 for the copper, whereas for the AC, instead of 0.868 ohm, it is 1.1 ohm is there. So this is the copper resistance per phase. Now there is a capacitance. So as this is the current carrying conductor over which we are using some insulation. Again, there is a one more conductor, one more core. Again, there is an insulation. So it is just like a capacitor. Two current carrying plate. In between, there is an insulation or dielectric material. So it acts as a capacitor. So the cable also form the capacitors along its length. So these are the specification of capacitance for the different size of cable. Now it is the current normal current rating. This is our very important point. So aluminum conductor 4 square mm, we will start from the 10 square mm. The 10 square mm carries current for 57 ampere in the ground, whereas in duct it is 48 and in air 53. Why these differences are there? In the ground, the temperature is going to reduce, means the temperature rise of cable will be smaller. Even in the dry season, in the say summer season, the temperature rise will be small. Therefore, the current carrying capacity or current handling capacity of cable is 57 ampere. Whereas in duct, because the duct is say it is going to expose to the sunlight or there is a atmospheric temperature. So the temperature of atmosphere is more, hence the current carrying capacity will be small, or we should carry the current up to the maximum 48 ampere. Whereas in the air, it is 53. So duct is there. Many times the duct are going to form in the industry. So duct, when the cable is laid under the duct, the current carrying capacity will be small. Now for the same size of cable, 10 square mm, the copper carries more current. It is 74 ampere in the ground, 81 ampere, 61 ampere in the duct, and 67 ampere in the air. So these are the some specifications are there. And for the short circuit rating for 1 second, if there is a short circuit is going to occur for the 1 second, but 1 second duration, it may carries current 0.094 kiloampere, and whereas for copper it can carries 1.43 kiloampere. So it is 10 into 3. So these are this much current can handle for 1 second. So this is some available chart is available for the different companies of cable. It may be the say L&T cable or whatever the cables are available. Phenolics cables are there or polycaps cables are there. Each manufacturer gives their charts. From this chart, it is easy to select the cable for the different application as per our requirement. Now, LT cable termination and joint. So joint is when two cables are connected. Say we want 100 kilometer or say 200-meter cable is there, and we want to connect with the second 200 cable, then it is called as a joint. Or sometimes the fault occur in the cable, so we have to do some joints. So these are the joints. So under such condition, we have to use some ferrule. This is aluminum lugs. It may be if the cable is aluminum, we are going to use aluminum cable, aluminum lugs, and if the cable is copper, then there is a copper lug. So it is in such a way that it is called as a cable joint. Whereas termination, if the cable is terminated in the transformer box, in the terminal box, it may be the, say, LT cables, LT panels are there. So here the copper bus bar is there, and in which the cable is connected. So it is called as a termination. When there is a bus bar is there and cable is going to terminate, cable is going to join, then it is a termination. Whereas if two cables are connected to increase the length of cable, it is called as a joint. Now HT cable, what is the difference between LT cable and HT cable? If you look to the construction of the cable, so this is the core. It may be a copper core, it may be aluminum core. So if aluminum, it's aluminum HT cable, and if it is a copper, then it is called as a copper HT cable. So this is core over which there is a conductor screening, means some insulation materials are there. Again, there is a XLPE cable, XLPE insulation, but the thickness of XLPE insulation is more than the LT cable, because in case of LT cable, the difference between two conductor, the voltage between two conductor is 1100 volt. Whereas for the HT cable, it may be a 11 kV cables are there, 33 cables, 33 kV cables also available, 132 kV cables are available. So the voltage difference between, or voltage between conductor to conductor is very high. Therefore, XLPE thickness is larger. Then there is a copper screening, because the static charges are there, though these static charges are going to grounded. So this is one copper sheetings are there, which will give some, avoid the some static charges. Again, there is a inner sheetings. Then armored is similar. Either it may be a round or it may be a flat armored. Then outer sheeting. So here the difference is that the XLPE thickness is more. There is a double sheeting, inner sheeting, outer sheeting is there. And the things is that in case of LT cable, the cables are very near to each other. Say suppose this is the LT cable, this is round one. So the is like this. This is the one core, this is second core, and this is third core. So here the insulation thickness between conductor to conductor is small. But here for the HT cable, if you just look at to the outer section, or say cutout section, so this is one phase, this is second phase, this is third phase. So this is way, and in between there is a insulation. So the insulation thickness is large. So this is 3-core aluminum HT cable is there. So this is core, this is XLPE insulation layer, this is inner sheet, that copper, then again inner sheet, armored, and outer covering or outer sheet is there. So this is the 3 conductors are there. So it is a 3-phase cable. Whereas sometimes the single core is also used for the 1 phase. The similar single core is used for the 2nd phase and 3 phase. So when the current carrying capacity is more, or you can say that the voltage is very high, then it is better to use, instead of single unit of 3-phase cable, it is better to use 132 kV for 1 phase, 1 cable, 2nd cable, and 3rd cable. So it will give the better result and better life. Now HT joint and termination, again it is very important, because here the insulation resistance is very much important. So if you do the termination, this is the termination joints are there. It may be the HT side of transformer or cable is connected to the conductor. Then there is a different type of coverings are there. This is first covering is going to lay. This is here, this cable. So this is one lead, second lead, third lead. Then these are the different, and it is mounted with the disc type insulators. We have seen in the many times we are going to see in the transmission line. So it avoid the water particle in the rainy season directly come to the joints or in between the cable. So it is just like an umbrella. When the water is there or rainfall is there, so water is going to drop outside the this one, so it will give some type of umbrella to avoid the water particle to enter in the joint is here. And it is a heat shrinkable sleeve. Heat shrinkable sleeve is that when we insert the sleeves over the conductors, 1, 2, 3 conductors are there, and if you provide the heat or flame with the help of some arrangement, it is get shrink. Means whatever the air pockets are there, whatever the say moistures are there, it is going to evaporate, and it is going to just joint very firmly, and it avoid to enter the water particle. So it is a heat shrinkable sleeves are provided, which will going to make a similar insulation between joint each other. Now these are the different lugs are there for the termination. This is copper lugs are there. It is aluminum lugs are there. So here the lead is provided, the copper lead or say aluminum lead, cable lead is connected here, and it is get crimped with the help of crimping tool. It may be a hydraulic crimping tool or hand crimping tools are there. By crimping, this is the crimped lug is there. Say this is first position. We have removed the insulation from part of the cable at the length of its similar length is going to measure. Then it is get inserted. After inserting, it is get crimped, and by crimping it become a firm one. So this is the lugs are necessary for the cable. For small cable, lugs is many times not necessary, but for 15 square, 16 square mm, 10 square mm, and more than say it's 15 square mm, lug is necessary. This is called as a ferrule lug, which is used for jointing the two cables. This is ferrule lug. This is also ferrule lugs are there. And this is called as a cable gland, because when we connect the cable has its own weight. And if the cable is just connected without compromising or without neutralizing the weight, this tension is going to occur at the bus bar. Or say, see here, if we are connecting the cable has its own weight. So because of this cable weight, it may break, this insulation may break, there may be a tension over this one. So to avoid this tension and the weight of the cable, one gland is provided. So gland is going to reduce, or it will take care the weight of cable and avoid any particle to enter the termination box. So this is the glands are provided over the cables. These are the multi-core cable, or it may be a control cable, which is used for the controlling, which is used for the different application, PLC and all these things. So there are number of conductors are there instead of 3-core cable. Generally the 3-core cable is the power cable which carries the current or which transmit the power from one circuit to other, whereas the control cable is used for transmitting the signal on off control, some pressure control and all these things. So multi-core cables are used, and generally these multi-core cables are unarmored because it is a flexible. It is going to use indoor purposes from one panel to other panel, from some sensor in the PLC or some SCADA system, so to transmit the data. So this is one kind of data cables are there, and to avoid whatever the static charges, it is get grounded. So these are the say these different type of cables, control cables are there. So measuring, what is the Megger? Megger is the tester is used to detect or to find the insulation resistance between two lead of the cable. So if the cable gives between two conductor or conductor to neutral, conductor to say armored, it should be more than 20 mega ohm. Then and then the cable can be used in the service. Otherwise, if the resistance between two lead resistance, insulation resistance between two lead is less than 20 mega ohm, then there may be a chances of short circuit, or it say that there is a deterioration or there is a failure of insulation. So this is the Megger which is used to test the cable. So one lead is connected in one current carrying conductor, that is the core, and second is connected with the second core, or it may be connected to the neutral. So we can carry the test between core to core, core to core. Then second is core to earth, core to neutral, and we can say that core to armor. So if the resistance is more than 20 mega ohm, if the resistance is more than 20 mega ohm, the cable is good condition, means we can put in the operation. So this is the some cable list testing methods are there. One lead is connected to the core, second lead is connected with the outer sheet, and third lead is connected here. Say for example, in the third case, armored is there. So the insulation resistance should be high between these 2 points. Insulation resistance should be more than 20 mega ohm, and for the HT cable, it more than 20 mega ohm. It may be a 50 mega ohm. So here it should be more than this one. So if there is a failure, the indication will be a short circuit, or indication will be a 0. Say here it is 0. So if the cable in the good condition, then it will be a 200 mega ohm, 100 mega ohm, 50 mega ohm, 20 mega ohm. And whereas if there is a failure of insulation, the pointer goes to the 0. So it means that the insulation resistance is 0 and there may be a dead short circuit. So whenever there is a fault occur in the cable, it is better to carry out the Megger test by disconnecting the cable. And definitely when we are doing the measuring of the cable should be disconnected from the both end. Otherwise, it may get the shock, or there is a fatal accident is going to occur. So in electrical, the best safety practices should be followed. So this is the testing of cable. Megger is used for testing of transformer, making testing of say motor. So Megger is nothing but the measurement of insulation resistance. So definitely for the induction motor, for any type of motor, there should be a proper insulation between body, metallic body, and enclosure, between enclosure and windings. Phase 1, phase R phase, Y phase, B phase. So here one lead is connected to the winding one, and second is connected to the earth. Similarly, we can go for the insulation resistance or measuring to the transformer between HT to ground, each phase from HT side to ground, between HT to LT, and LT to ground. So whatever different combination, we can go for the insulation testing. So thank you for this one. Cable testing up to this one. So next time we will see the different part of this lecture series. Thank you.